So let's go ahead and move on. All right, this one says, so if f of x equals minus 6 plus 11, find x so that f of x equals 11.5. And it tells us that don't be afraid, the answer is a decimal. Okay, that's cool. All right, so this time what they've done is they've given us f of x. Remember, f of x is just y. So f of x is right here. So that means it's going to be 11.5. Okay, so we're going to have 11.5 equals negative 6x plus 11. Okay. So first thing we want to do is we want to go ahead and subtract 11 from both sides. These guys go away, so I get minus 6x equals 0.5. Okay? So then we divide both sides by negative 6. All right. So normally we have a 1 on top. We've only got a 0.5. So if we multiply that answer by 2, we're going to get minus 1/12. Okay. But let's go ahead and do the decimal like they said. So we'll break out your calculator. Let's bring him into the picture here. All right, so we bring that in. We say, okay, we've got 0.5, and we divide that by 6. And we know it's going to be negative. So it's minus 0.83, and the 3's just repeat. And that's how they tell you that the 3's repeat. They just put a little line over top of it. Okay. So if they want it as a decimal, it's this guy. And again, these tests are usually multiple choice, so they'll probably have it written as 0.83 if they want a decimal. All right. Let's go ahead and check out a few more. So it says, which relation is a function? Okay, so we got some ordered pairs here. Here's how we do this. All you need to know, you look at the first term in each of the pairs, okay? Those are our x values. To be a function, we have no repeated x values. Okay, so let's look here. So here's a 2, and here's a 2. So the x values repeat. That's not a function. The next one, we've got 2 minus 3, 3. Okay, so we get 2 minus 3's in this guy. So no. Next one, we get 2 minus 8's. So no. So we're assuming that the last guy's it, but let's make sure that they didn't mess up. So we get minus 3, 6, 5, minus 6, and 3. So they're all different. That's all you're looking for to tell if it's a function. Just make sure all the x values are different. And that's it. So that one's pretty easy. That'll be some easy points if they throw that one on there. All right, let's go ahead and move on. All right, so it says the water pressure P of a submerged object varies directly with the depth D. So if you've ever gone down deep into some water, it's got to be usually about at least 10 feet. They don't make pools that deep anymore. They used to. You can really feel the difference, like on your, particularly around your ears and stuff like that. So it says at a depth of 50 feet, the water pressure is 5,400 pounds per foot squared. It says, what is the independent variable in this situation? Okay, so basically what this is saying is it varies directly with the depth. So water pressure varies directly, so it's going to be some sort of constant here, and then with the depth. Okay, so what is the independent variable? So the independent variable is D, because the amount of pressure depends on the depth. Okay, so the independent variable again is going to be D. Or not, yeah, independent. So that's the variable we change. So the deeper you go, the more pressure you get. I think probably the most logical version of this is like if you have a job. You work at Taco Bell, they pay you $11.25 an hour. I happened to see that on one of their signs the other day. So the amount of money you make is dependent on how many hours you work. Okay, so the dependent variable is how many hours do you work. Then the independent variable is how many hours you work. The dependent variable is the money. Okay, more hours means more money. All right, so next one we're talking about here. So it says a student is selling baseball caps for a fundraiser. Situation is represented by this guy right here, where C is the number of caps sold and P is the profit. So what is the dependent variable? So the dependent variable in this one is P. Okay, so that's the dependent variable because again it depends on how many hats do we sell or how many caps do we sell. Okay, so the more caps you sell, the more profit you make. Does that make sense? So that's all they're looking for there. So the dependent variable is the one that we change, and the independent variable is the one we change. I don't know why I keep saying that backwards. The independent variable is the one we change. The dependent variable is the result. So think of it that way. Independent variable we change. Dependent variable is the result based on the value of the other variable. All right. It might be Thursday, but it feels like Monday. But we're all glad it's Thursday. All right, let's check out a few more. So it says the function h of n gives the number of person hours it takes to assemble n engines in a factory. What is a reasonable domain for h of n? Okay, non-negative rational numbers. So our domain is the number of engines, right? So based on what they're saying here, we must be talking about completed engines, right? So rational numbers can be like 1/2, 1/3, 5/3. Anyway, they can be things that aren't a whole number. So I'm thinking that's not our guy. The real numbers, that includes negative numbers. I don't think we can make negative engines, so he's out too. Okay, non-negative integers. All right, that sounds pretty good because if the real numbers are out, non-negative real numbers are out too. So I think this is our guy. So integers are like 0, 1, 2, 3, 4 if they're non-negative. So they took the negatives out because, like I said, you can't build negative engines. So that's the one that makes the most sense. Okay. Pretty easy. All right, let's go and check out a few more. Okay, so these are just number crunching. Let's go ahead and do some of that. So again, what you do when you're raising to a power is we just it's almost like the distributive property. So this guy's going to be 3 to the second power. So it's going to be 9, right? And then the exponents, you multiply exponents when you raise them to a power. So 2 times 2, this will be x to the 4th. And here we've got 3 times 2, so it's going to be y to the 6th. So that's your guy. All right, now with these kind of problems, I probably said it in the instructions, I didn't write them down, but they usually want positive exponents. Unless they say different, they're looking for positive exponents. Okay, So this next guy, all you have to do with him is the 3 is going to stay on top. The b to the 6 is still going to be in the bottom. And then to move this guy to the bottom, again, this was kind of like a problem we did a little bit ago. All you have to do is switch the sign on the exponent. So this becomes a to the positive 8. Okay, so that's all there is to that one. All right, the next one. Now, like I say, if these are multiple choice, first thing we always do is we're going to go ahead and multiply the two numbers together. So we're going to start off with a positive 20. Check your answers. If they don't start with positive 20, they're wrong. Cross them off. Okay. All right, and then when we're multiplying, we just add exponents. So this is going to be 9 plus 2, so that'll be x to the 11th. And then if there is no exponent, remember it's just to the first power. So I have 8 plus 1, so this is going to be y to the 9th. Common thing people do is they forget to add the 1 when it's just a y. Okay. All right, so next one, like I say, same thing, positive exponents. So this is 8 to the minus 3, and technically you could put it over 1 if you wanted. Okay, but if we move him downstairs, he becomes 8 to the positive 3, and then 1 over that. And then we can figure that out on our calculator. So 1, and then we got 8 to the 3rd. Let's get him back into the play here. So 8 raised to the 3rd power is 512. So this will be 1 over 512. Okay. All right, so next one, we reduce the fraction. So first thing you always look at a fraction is, do we have even numbers for both? In this case, we do. So that means we can divide by 2. So 22 divided by 2 is going to be 11. 6 divided by 2 is going to be 3. So we're done with that part. Okay. And then here we just subtract the exponents. So this would be 8 minus 1. So that's going to be x to the 7th. And over here, we've got 1 on top. We've got 4 in the bottom. So if you do 4 minus 1, that's 3, but it's going to be positive 3 if you leave it in the bottom. So that's our guy. So if you have 1 y upstairs and 4 y's downstairs, you can cancel out one of the y's, but you still have 3 y's downstairs. And the last one's super easy. Anything raised to the 0 power is 1. And that's it. Questions on any of those? You cool? All right. So let me check out a few more. All right, so this is kind of more of the same, at least this one is. But they get a little fancier as they go along. All right, so same deal here. So this is really 4 times 1, so that's just going to be a 4 on top and just a 2 on the bottom. Okay. Oops, my bad. I forgot to square this guy. All right, so that makes him 4 times 4. That would be 16. All right, so let's do that. All right, so that's 16. Now again, we've got 16 on top, we've got 2 on the bottom, so it's really 16 divided by 2. So we could just make this thing into 8. So let's go ahead and do that. All right. And you can do this at the end as well. But since we noticed it right now, we can go ahead and do it here. So instead of being 16 over 2, let's just make this 8 on top. And then we won't have a number on the bottom because they don't write the ones on the bottom. You could, but they probably won't do it. Okay. All right. So then next up, I'm going to raise this guy to the second power. So he becomes a to the 4th. Okay. And then we've got b to the 1st raised to the second power. So that's going to be b squared. And that 4 is going to drive me nuts. Hang on. Let's fix him up. All right, then we're going to multiply that by a b to the third. We'll come back to that, but let's see if we can do some canceling of this stuff on the bottom. So we already canceled the 2, so now we got a to the 4th and b to the 7th. All right, a to the 4th over a to the 4th. Beautiful. Let's cancel those out now. All right, so he's gone, he's gone. All right. Now, let's go ahead and multiply what we got left on the top. So this would be 8a. So we got the 8, we got the a, we got b to the 2nd, b to the 3rd is b to the 5th, and all we got left on the bottom is b to the 7th. Okay, so we've got 5 b's upstairs, 7 b's downstairs, so we can cancel out 5 of them. So all we're going to have on top is the 8a, and on the bottom, if we canceled out 5 of the 7, we've just got b to the 2nd left, and that's our guy. Okay, so there's a bunch of different ways that you can do that one. But that's where you want to get, is to this guy here. Like I said, there's different ways you could do it. We could do everybody all at once and then start canceling. We sort of canceled as we went just to try to keep things a little simpler. But whatever works for you is fine. Okay. All right, so the next one we have to add the exponent. So the biggest pain in the butt here is just adding 2 fractions. So we go ahead and do that, and then we're going to stick an x next to it and we'll be done. So all we have to do is we're going to add 1/3 plus 2/7. Okay, so one way you can think about these when you have to add fractions that don't have the same denominators is I try to make sure everybody's represented. Okay, so I've got a 3 on the left, but I don't have a 7, so it means I have to multiply by 7. And the second I do that, the top starts screaming, hey, we want to be multiplied by 7 as well. So we do that. Then when we go to the next term, we got a 7, but we don't have a 3. So we say, okay, let's multiply by 3. And if you multiply the bottom by the 3, you got to multiply the top by the 3. All right, so we just multiply straight across. So 1 times 7, we got 7 over 21 plus. Here we've got 2 times 3, that's 6. Also over 21, that was the point. Once we have the same number on the bottom, just add the numbers on the top, right? So that's 13 over 21. So since this is an exponent, it's just going to be x to the 13 over 21 power, which is obnoxious, I know. All right, questions on that one? So it's just adding the exponents, but the exponents are kind of a pain to add, is all it is. All right, so next one says write in radical form. So that means with a square root sign. So the a goes here. The number on the bottom goes out front. So it's 7, and the other number goes inside. So that's our guy. So the bottom number goes up front, the top number goes in with the variable underneath the square root sign. And that's it. It's really that easy. All right. So let's go and check out another one here. Let's switch up our colors a little bit. All right, so we've done some of this stuff as well, but people have a little bit of trouble with this one. So what do we want to do here? Well, one way you could approach these is you could say, well, I know my perfect squares. And my first perfect square, well, my first perfect square is 1 times 1, but that doesn't help. Because you multiply something or divide something by 1, nothing happens, right? So the next one is 2 times 2, that's 4. All right, so we say, well, does 4 go into 48? And if you're not sure, check your calculator. So we go 48 divided by 4 is 12, okay? So I could rewrite this as the square root of 4 times the square root of 12. Okay, so before we move on, we can ask ourselves, can I divide 12 by 4? And grade school taught us that, yeah, we can, right? So we're going to have the square root of 4 times the square root of 4 And then 4 times 3 is 12, so we have the square root of 3. Okay? Now, if you multiply two numbers that are the same under square root together, you just get the regular number. So this would become the square root of 4, and then times the square root of 3. And that's what they're looking for. That's our boy. Everybody hates fractions and square roots, so we try to make them as small as possible. Okay? All right, so next one says we've got 4 times the square root of 20. So again, we'll start with our guy 4, which is 2 times 2. So we could rewrite this as 4 times the square root of 4 times the square root of 5, because 4 times 5 is 20, right? And the reason we picked that perfect square, because if you take the square root of 4, you get 2. So this guy becomes 2. We multiply the 4 and the 2, that gives me an 8. And then the square root of 5 we bring along for the ride. And that's our guy. Okay. All right, so the next one says 40 to the 1/2 power. To the 1/2 power is the same as saying the square root of 40. Now it looks like our last two problems. Okay, so again, it looks like 4 will go in there. All right, so we're going to rewrite this as the square root of 4 times the square root of 10. Because 4 times 10 is 40. And again, the square root of 4 is just 2. And then the square root of 10 we can't do anything with, so that's our guy. All right, so our last one is the cube root. When you say 1/3 power, that's the cube root of 40. So that's going to have a little 3 here. Technically, they should put a 2 here, but they don't. That's just one of those lazy math guy things. So this is the cube root of 40. So now what we're looking for is perfect cubes. Okay. So instead of multiplying the number 2 times in a row, we're going to multiply it 3 times in a row. And we'll start with 2. So 2 times 2 is 4, and 4 times 2 is 8. So 2 to the 3rd power is 8. Okay. Well, as it turns out, 8 does divide into 40, right? So we can say we've got the cube root of 8 times the cube root of 5, because 5 times 8 is 40, right? So again, the perfect cube is 8, so if you take the cube root of 8, you just get 2, and then times the cube root of 5, and that's our guy. Questions? Okay. We'll do 1, maybe 2 more, and we'll call it. Okay. Because obviously when nobody else is here, we get stuff done a lot faster. So, I mean, we've done a ton of problems already. So let's see what this one's all about. Okay, it says label the follow as irrational or rational numbers. So the only ones that are irrational are ones that don't repeat a decimal, or a decimal doesn't stop. Okay. Pi is an irrational number, so we know what to do with that one when we get to it. And any square root that isn't a perfect square will give you an irrational number. So that's our definitions here. Rational means ratio. Okay, you see ratios right in it. So that means we could write that as a ratio of two numbers. So even if it was like, 10, you could write that as 10 over 1. So it's a rational number. It can be written as a ratio. So that's the point of a rational number. All right, so the first guy, 16, square root of 16, that's a perfect square. That'll just give us 4, right? So then this guy, we're just going to use R and I. So he's rational. Now the square root of 15, that's not a perfect square. So he's going to be an irrational number. Okay, so 1/3 is a fraction, right? But it's still a ratio of two numbers, so he's a rational number. So we'll give him R there. All right, so this one, if they repeat, which this one's repeating 0.25 over and over, that's okay. That's a rational number because you can definitely express that as one number over another number. And a simple example of that is 1/3. If you take 1 divided by 3, you get 0.33333, and it never stops. It keeps giving you more 3's, right? But you can still express it as 1/3, so it's rational. So this can be expressed as some rational number, some fraction. I don't know what that fraction is off the top of my head, but it can be done. All right. So if it repeats, then you're okay. So then that makes this guy rational as well. Now this guy, this is where they get a little tricky. You get these dots here, right? So that means this thing keeps going. Okay. And we don't see any kind of pattern like we did with the 0.2525, right? So I think they're figuring that this is going to be an irrational number. Okay. Now, if those dots weren't there, this would be a rational number because it would stop here at 1, but it doesn't. That's what the dots imply, that it keeps going. So that makes it irrational. Pi, we already said is irrational. That's easy. Okay, and then the last one, minus 100. It's okay if it's negative because this doesn't have a decimal that doesn't repeat and doesn't stop. There is no decimal, so we're fine, right? So being negative is okay. So negative number is still a rational number. So it's just a little definition stuff for us there. All right. And that's probably a good stopping point for today. All right, Gabe, I want to thank you for stopping by. And hopefully we'll see you next week.